All right, let's keep going. So we're just doing a whole bunch of examples here on rational equations. And for the next one, the nice thing here is the denominator is already pre-factored, right? It's just x minus 4 in each case. There's no squares here. There's nothing in common. So I'm ready to jump right in. Because I only have one denominator, my LCD is going to be that x minus 4. Keep in mind that this is all stuck together, right? So it really is, together as a factor here. So I'm going to multiply both sides by x minus 4, which means all the terms. So I have x minus 4 for the first group. I have x minus 4 for the second group. And then don't forget, you still need it for the number 1. It has to be consistent. And then what I'm going to see is that my x minus 4 denominators cancel out in both cases. So what's left here is 2x. Here I just have an 8 left. Now here I do have 2 things left, but I'm just multiplying by 1, so it's not going to change it. And I have x minus 4. Cleaning this up, I have x on the right and then plus 4. And I'm going to go ahead and subtract x from both sides. And I get x equals 4 for my final answer. Now this one, when you go to check it, you're going to see an issue right away. So I'm going to plug in the 4 here, but what happens, if you're hopefully noticing, is that you're getting a denominator of 0, right? This becomes 8 over 0 equals 8 over 0 plus 1. So this right here is a huge issue. And you may have noticed that right away. If you were looking at your domain in the beginning, you may have noticed, hey, I have these denominators of x minus 4 here. That cannot be 0, right? It can't be 0. So you see pretty quickly on that your answer cannot be 4. So this answer is not valid. It does not work. Because this was the only answer we had for this problem, this must be no solution. So this particular equation has no solution here. Okay, let's do another one. Again, this one is kind of nice where the denominator is pre-factored. There's nothing I have to do here. And I have the same denominator in both cases, so my LCD will just be x minus 2. And I'm going to just multiply everything through by x minus 2. So each of those terms I'm multiplying through. And I do see that, my denominators are going to cancel. And what I have left here, you do want to be careful. You do need to distribute that x throughout. So I get x squared minus 2x. In my next group, I just have a 14 left. Here, I just have a 7x left. Here, multiplying by 1 is not going to affect it. So I get x minus 2. I have x squared minus 2x plus 14 is equal to 8x minus 2. And I'm going to bring everything to the left side here. So I'm going to subtract the 8x. And I'm going to add the 2. And I have x squared minus 10x plus 16 is equal to 0. Okay. So now that's as clean as I'm going to get it for right now. I see I have an equals 0 on the other side, and I have a quadratic, right? So I have a square here. So I would try to see if we can factor this first. This one's going to be factorable because that's the main technique we have been using as of right now. But again, there's lots of ways to solve quadratics. So if I factor this, let's see, I would get minus 8 and minus 2 here as my 2 factors. And then I can set each factor equal to 0. And here I would add 8 to both sides, and here I would add 2. And what I'm getting for my answers are x equals, 8, and x equals 2. Now, one of these I actually can throw away pretty quickly. Again, if you look at your denominators in the beginning, we cannot have division by 0. So right away, x cannot be 2. So I'm not even going to bother plugging this in because I can see right away it's going to give me a denominator of 0. So that one is not going to work. I do have to check out the 8 though. So you can't just, skip that step here. let's see, I'm running a little bit of room, but let's check the 8. I'm going to go back to the original. So I would have 8 plus 14 over 8 minus 2. 7 times 8 over 8 minus 2 plus 1. So that's 14 over 6. And then this is 56 over 6 plus 1 here. Now, again, I just need to make sure these two things are the same. So I'm going to be a little bit lazy here. I don't really feel like doing common denominators. So what I'm going to do is just use my calculator. So on the left side, I have 8 plus 14 over 6, which is 10.3333. On the other side, I have 56 over 6 plus 1. And you can see that they're the same. Right? In each case, I get 10.33 repeating on both sides. So here, again, I could do common denominators, but I'm just going to save myself a little bit of time. I just need to make sure they're the same, and this does work out. So you do have one solution here, and that is going to be x equals 8. So that is our check. All right. The last example we're going to do for this video is one where we have multiple variables in it. So here you have a, b, and x. So here they're going to ask us to solve for a particular variable. And remember, we've seen these before, so you're just going to treat that as the only variable, but still follow, the same basic techniques. So here we're going to pretend like x is the only or the main variable and just solve to get x by itself. So we're trying to get x alone here. Now I do see 3 denominators. So my LCD here is going to have to be a, b, x. So a times b times x. So I need all 3 denominators. And I'm going to start by multiplying through by that. Now notice that I haven't actually even thought about which variable I'm solving for. If I see fractions, I'm just going to cancel them right away, no matter which variable I'm solving for. The same thing if you had parentheses, like I would do parentheses first, then cancel my fractions, and then start thinking about, okay, what variable am I solving for here? So in this first case, the a's are going to cancel. Here your b's are going to cancel, and then here your x is going to cancel. So what you have left over here is 1 times b times x, so that's just bx. Here you have a times x times 1, so that's just ax. And on the other side, you have ab. Now at this point, I'm trying to get x by itself. So whatever variable you try and get alone, get all of that on one side. So notice that my x's are already all together on the left side. Now this is kind of funny because I can't really add them the normal way here, right? It's not like 3x and 2x, but my x's are together. If I was solving for a, for instance, I'd want to get my a's together. So whatever you need to do to get that variable on one side. Now, if I have something more complicated like this, I can work with the x. What I'm going to do instead is I'm going to go ahead and factor that x out. So if I factor the x out, I'm left with a b plus a. Notice you could also have it like this, a plus b. It doesn't actually matter because addition is commutative. And then I'm able to divide by that on both sides. So x is equal to ab over b plus a, or ab over a plus b. Again, you could also have ba up top. There's a few different ways that you could write this because multiplication and addition are commutative. But this would be our final answer. Now for these, you could check this by plugging it back in. So you would plug this back in for x. You would end up, because you have division here, you'd end up using the reciprocal and flipping it, and you'd have to use common denominators on the left to actually check this. But it does check out. These ones you probably don't need to check as much because you're not really getting an answer to really plug in. But if you're unsure if you've actually solved for the x correctly, you could plug this back in and see if you get back out a true statement as well. So you can do that here. Although, again, you really shouldn't be getting extraneous answers here because we're not actually getting a real answer. We're just solving for a particular variable. So the techniques we've used today can be applied in that case as well.